In this series, we will build a multiplayer Wordle web application using Python. We will learn the basics of front-end development using HTML, CSS, and JavaScript, and backend API design in Python using Flask. We will also discuss the Websockets protocol, which will enable us to establish and maintain bidirectional communication between the server and connected clients. I am dividing the series into two parts to make it more digestible. In the first part, we will discuss the front-end design and go through the HTML, CSS, and JavaScript code for the website. Then, in the second part, we will go through the backend API design in Flask and the Flask-SocketIO library to create WebSockets. At the end, I will release a video with both parts for those who would like to complete the project in one sitting. As always, the code will be available on my GitHub, linked in the description down below. Before we jump into the project, I want to demonstrate how you can download and run it. Keep in mind that you need Git and Python installed on your machine to follow along. All the commands are in the README in the project repository. We'll first clone the repository into our terminal and enter the repository directory as follows. Next, we'll create a Python virtual environment to localize our project's dependencies. In Windows, this can be done using the following command. However, if you're on Linux or Mac OS, you would have to change this to be Python 3. Let's give it a moment. After the virtual environment is created, we need to activate it. In Linux, this would work using the following command. But on Windows, we have to use the following command. If it works, you should see this green Venv text. Now, we need to install the dependencies and packages that will be required for our project. I have included a requirements.txt file that has all the requirements for the project. We can install this as follows. Once again, if you're on Linux or Mac, you need to change this to pip3 install. Let's give it a moment to install all the packages. Now we can finally run our application. To do this, use the following command. If you are on Mac or Windows, change the Python to Python 3. The app will now give you a link to view the website. You can play with others in your local network by sharing this link with them. When you click on the link, you will be brought to this web page. Here, we will log in by entering the username, and we'll create a new lobby. I have another tab with the same website to have multiple players in the same lobby. We'll log in here as well, and we'll join the room. The room code is 482777 here. After joining, only the creator of the room can start the game. Once the game is started, it will work like a normal Wordle game. You get 6 guesses to guess the word. I'm going to use a cheeky strategy of guessing 25 of the 26 letters in my first 5 guesses. And hopefully, I can get the answer. So the letters are M, O, L, E, and A. Maybe a mole is the word. It was. So that took me 42 seconds, and it took me 6 guesses. Here I will guess it first, and At the end, you will see a leaderboard, and you can always start the game again. And only the host of the room can start the game. That's the demo. Feel free to download the code yourself and play along with your friends. And I'll see you in the next one where we discuss the front-end development. Welcome to the first video in a two-part series where we build a multiplayer Wordle web application. In this video, we will focus on the front-end development of the application. We will delve into the HTML and JavaScript code, as well as discuss the design decisions I made. By the end of the video, you should have a fully built website with JavaScript code to communicate with the backend. Without further ado, let's jump into the code. Let's first walk through the HTML. At first, I wanted to have different HTML pages for different parts of the web app. I wanted a login.html page for the login page, a lobby.html for the lobby, a room.html, and so on. The main issue with this is that to navigate between pages, we would need redirects. This, however, does not work well with a WebSockets connection, because with every redirect or a page reload, the WebSockets connection is reset. So, in order to keep the user logged in, we would need to use session variables to store their information and restore them whenever they reconnect to the server. The problem, however, is that we cannot distinguish between a user leaving the web app and redirecting to a different page in the web app. Also, cleaning up when the user disconnects from the server is also tricky. This just makes it needlessly complicated, and we can always find a better solution. This is when I had the idea to create a single web page with all the pages enclosed in their own div tags. This way, we can set one of the pages to be visible by activating that particular div tag and hiding the remaining div tags. This avoids the page redirects and maintains a single WebSockets connection. When the user makes an action in one page to transition to another, the current div will get hidden and the next div will be made visible. This is in fact very similar to how the JavaScript framework React works. It uses a single web page, and based on user actions, it reacts to them and updates the DOM. The main difference between React and this implementation here is that React is simply more efficient and utilizes more complex data structures to implement additional features. However, for a simple web application, this concept and its implementation is plenty. If we step through this HTML here, you can see that this part here is the login page, this is the lobby, and so on. Each of them is enclosed within a div tag, which can be set to be visible or not, depending on which page the user is currently on. The login page requests the user to enter their username. The lobby page has options for them to either join an existing room or create a new room by themselves. The room page is a common place for all players to join before starting the game. The game page takes in user guesses, shows their current time, their character usage on a keyboard, and their recent guesses. And finally, the end page allows the players to start a new game and shows them their leaderboard in the current round. You can also see that I'm including the socket.io JavaScript library here, as well as our script.js, which is where we'll be implementing WebSockets connections between the front end and the back end. Now, let's move on to the CSS. The CSS is mainly to add some color and make the website look fancy. We just don't want it to be bland. So let's not spend a lot of time here, as most of it is completely subjective. Feel free to edit this file if you want to improve on the design and go through it to understand the different properties that are being used that you can modify. Finally, let's get to talking about the JavaScript, which is what adds most of the functionality for the front end. Up top, I have defined a bunch of functions that can turn on and turn off the divs controlling the different pages. This way, depending on the current page that the user is on, we can display the HTML relevant to only that. I've also defined a standard message function, which is how the backend will communicate any errors to the front end, and the front end can display the errors to the user. Here, we set up an initial page load where we turn off all the HTML pages except for the login page, which is where the user would start. We also define a bunch of page functions here. so that the front end can communicate with the backend on what the user's current actions were. So there is a function to log the user in, to create a new room, to join a room, start a game, and guess a word. Each of these functions uses WebSockets to communicate to the backend. So there's a function called socket.emit in each of these functions. This takes in an endpoint to communicate to, as well as a JSON object containing information that is to be sent to the backend. In the next video, when we're discussing the backend, we look at how we can access the fields in this JSON object and use them to update the game state for each user. We also have a bunch of helper methods here to display helpful information to the player. We have print guesses to print the player's guesses in the current round. We also have print keyboard to print the keyboard usage of the player. And we have print leaderboard to show how the player has performed compared to the others in the room. I've also added a bunch of event listeners for the buttons that are present in the HTML. This way, anytime either of these buttons are clicked, we can call the corresponding event handler function up top, which would make a call to the API endpoint in the backend using WebSockets. There's also a stopwatch function to display the user's time in the current round. And we have a bunch of functions that receive communication from the backend and set up the HTML page. We have a function for a valid login, for an invalid message that could come from any part of the application, a valid room if you're joining one, a valid game load, as well as valid guesses and the end page. Feel free to step through this code to understand what each function is doing. I've tried to write it in as clear a way as possible so that you can read it and understand what each function is trying to accomplish. And that is it for the front-end design. For the backend, we need to set up classes and functions to handle requests from the front end, maintain user data, and execute game logic. We'll look into that and setting up WebSockets on the backend in the next video. I'll see you all then. In this video, we will be completing the multiplayer Wordle project by writing the code for the backend. Based off the poll results last week, most of you want me to write the code in the videos rather than just talk through it. So from this video on, I will be making that change. If you do, however, want to just look at the code, you can find it on my GitHub linked in the description down below. Now, without further ado, let's jump into the code. There are 5 main files in this project. First, we have app.py, which will coordinate the entire backend and communicate with the front end. Then we have webserver.py, which will contain the website logic on the backend. Next, we have room.py, which will contain the definition of a room class. We have player.py as well, which will contain the definition of the player class and hold player-specific attributes. And finally, we have game.py, which will contain the definition of the class to play the Wordle game. We will build the project from the bottom up, starting in game.py. The main goals we want to accomplish in game.py is to write a class that does the following. We want a class that will handle the game logic. That is, it will check whether the user guess for the Wordle word is correct, and if it is not, return the status of each character in the guess. And we wanted to generate the Wordle word for each round. Now, if we look at these requirements carefully, we can see that there isn't any specialized function that each instance of a game class would need to perform. That is, every class will have to handle game logic, which we can write pretty generically, and will have to generate a Wordle word. So we could accomplish all this if we had just a single instance of the game class. To achieve this, we will use the singleton design pattern. The singleton design pattern ensures that within the lifetime of the program, there is only one instance of the current class ever created. To define a singleton class, we first create the class. In this case, we'll name it class game. And then we'll define it as follows. We will first create a class variable called instance, which we'll set to none at the beginning. Then we will override the new method, which is what Python calls whenever an instance of a class is being created. We will accept the following arguments. And we first want to check if the instance variable in the class is equal to none. This checks if an object of this class has already been instantiated or not. In this case, if there is no object of the class, we want to create it. And we'll create it as follows. We will set it equal to an instance of the class by calling the new method of the super object. In Python, every class that we define is derived from a object class. So by calling the super's new method, we can create an object. Finally, we will return this object from the new method. In essence, what this new method does is, if there isn't already an instance of the game class that has been created, it will create it, and then it will return that instance. However, we don't just want to create the game class instance, we also want to initialize it. So we will write the init method. We want the game class to store all the words in our Wordle dictionary, and I'm storing all the words in this plain text file words.txt. So we'll open and read in the words in this file in the game class. To do so, we'll accept a file name argument. And in here, we'll open the file using the context manager in the read mode as file. And we'll store all the words in the attribute words. Line.strip for line in file.readlines. This list comprehension will read in all the lines in the file, and then it'll strip out any new line characters or white spaces to the end and store the words in self.words. We'll also create a set of these words and store it in word set. This will make it easier for us to check if a word already exists in the dictionary later on. Next, let's write a method to generate the game word. Here, we will pick a random index in the words list, and we'll return the word at that index as follows. Randint 0 len self.words -1. To use the randint function, we'll have to import it from the random library as follows. We also want to handle the game logic in this class, so we'll write that as follows. We'll write a run guess method, which takes in the user's guess and the original word, and it will return the status of the guess. First, we want to convert all the letters in guess to be lowercase using the .lower method. Then we want to check if the guess is in the word set or not. If it's not in the word set, we will return that the word is not in the dictionary. If it is in the word set, Then we'll check quickly if the guess is equal to the original word. If it is, we will return that it is the correct guess. And finally, if neither of these options are true, we'll return a list containing the status of each character in the guess. To do this, we'll call another method called validateGuess and pass in the original word and the guess. Let's also write the validateGuess function now. So we pass in the guess and the original word. This function will compare the guess to the original word, and it will return whether each character is in the right position, or if it's in the wrong position but it is in the word, or if it does not exist in the word at all. To implement this, we'll create a return list. The list will contain information about the characters in the guess and their status as follows. So we'll first iterate through every character in the guess, and by default, we'll set that the guess is incorrect. I wrote this chrordc-32 to convert the character from lowercase to uppercase. And I'm using 1 to indicate that this guess is incorrect. We'll also create two lists, not G and not W. We will use these two lists to determine the letters that are in guess and original but are not in the correct position. The main logic for determining this is as follows. We'll first iterate through every character in the guess. And the easiest check is if the character is in the correct position. So if the character matches the character in the original string at the same index, that means it's the correct letter at the correct spot. We can simply update this character's status in the return list to be correct. So ret I1 will be equal to 3, where 3 indicates that it's the correct letter in the correct spot. If it does not match the character in the original string at that spot, we will store it in the not G array to be processed again at the end. We'll also store the character at that position in the original string in not W. After we have processed the string once, we'll go through the characters that have not been matched. So for the character in index in not G, now for each character that was not matched, if the character is in the characters in the original string that were not matched, then that means that this letter is in the original word, but it is not in the correct spot. So we'll store its status as follows. Correct letter, incorrect spot. We will also remove the character from the not W list so that it does not count multiple times. Finally, from this function, we will return the ret list. Now these status numbers, 1, 2, and 3, correspond to the indices of the colors that we used in the JavaScript. If I pull that up here, the colors array in the JavaScript, The color at index 1 is black, which would indicate that the character is not in the original word. Index 2 is orange to indicate that the character is in the original word but in the incorrect spot. And index 3 is green to indicate that the character is correct and in the correct spot. That is all the code for the game class. Let's now jump into the player class. The player class is pretty straightforward in that it will store attributes for the players that are relevant in each round, and it will reset them in between the rounds. This way, we can keep track of the player's stats during each round. Let's define the player class now. We'll write the constructor for the player, and we'll take in two parameters, the player name and the player ID. For each player, we want to store a keyboard. This will contain information about the characters that they've used so far in the round and the statuses of those characters. We also want to store their guesses for the current round. Then the time that they've taken, or if they've completed the puzzle this round, which will be false by default. We want to store if they have finished the current round, which is either by guessing 6 times or by guessing the correct word. And then we'll also store their name, which will be player name, and their ID, which will be their session ID or player ID. And there should not be a space here. That's it for the init function. Next, let's write the reset function. This function will be called every time a new round begins. Reset these player attributes. We will first clear the guesses list using the clear method. Then we'll set the time to be 0. We'll set that they haven't completed the round and that they haven't solved the round either. We also want to reset their keyboard, which we will do as follows. This is a bit long and you might want to just copy this over from the GitHub. So we're just storing each character in the keyboard, the QWERTY keyboard, and the status as 0, that is that the character has not been played yet. This is mainly so that the front end can display this keyboard nicely on the game page. We have one final method to implement in the player class, which will be update after guess. Self, result, and time are the arguments to this function. The result is the list that will come from the game class, and this method will update the internal attributes of each player. First, we want to check if the result is equal to CS, which is, did the player complete the puzzle on this try? If it is, we'll set that they are done with the puzzle. We will set that they've completed it successfully. And to their list of guesses, we'll append CS. This will be useful later on when we want to update the leaderboard in the room class. We have a couple more branches to check here. Result could be equal to word not in dictionary. In this case, we'll simply update the guesses list to contain word not in dictionary, and we'll handle logic with respect to that in the room class. We do not want to penalize the player for guessing a word that's not in the dictionary. because they could guess a word that is more than 5 characters, or just a word that is not in our dictionary, and we do not want to penalize them or give them any information using an invalid guess. Finally, we need to update the attributes when there is a valid guess, which is not correct. We'll do that as follows. We'll iterate through each character and color in the result. The color is simply the status 1, 2, or 3, and C is the character. Here we will check using the walrus operator if the character is in either the first, second, or the third row of the keyboard. I'll just type it out before I explain. What this is trying to do is it's going to check in this string, QWERTY which is the first row of the keyboard, if the character is in there. If it is, it will return the value to be the corresponding position, and if it does not in the string, then it will return -1. We're going to check if the index, the found index, is not equal to -1, that is, it was found within the string. And if it was, then we will update the keyboard, the first row of the keyboard, at that particular index, and we want to change the color to be the maximum of this color and self and its current color. The reason we're taking the maximum is that you could imagine guessing a letter which turns out to be in the original word but is not in the correct position, and then on the future guess it does turn out to be in the correct position. Then you want to update the color to be from orange to green. So we want to use maximum here to make sure that the color is the most updated value that it can be. We'll use a similar strategy to update the keyboard if the character is in one of the other 2 rows. So the second row would be ASD, FGH, JKL. And here we have to update this to be 1 because it's the first row. And finally, the last row would be ZX, C, VB, and M. And we change the 0 to be a 2 in these 2 places. Then we will append the result to the guesses list. If they have guessed 6 times, then they are done with the game. So we'll set that attribute to be true, but we will not set that they have completed the game. Finally, we will set the time to be the time that was passed into the function, and we will return whether the player has completed the round or not. That is it for the player class. Let's now move on to the room class. The room class will be pretty involved because it needs to store the players that are in the room, the leaderboard of the current room, the status of the current room, whether there is a round being played or not, and have functionality to add and remove players from the room. To achieve all of this functionality, we will define a room class as follows. We will write the init method, and to the init method, we will pass in the host name and the host ID. In here, we will store the word. This word will be updated at the start of each round. At the beginning, when it's initialized, it will be set to none. We'll also set the host of the room to be the host that was passed in. The players in the room to be a dictionary, with the host also being a player. The dictionary will contain mappings between the names of the players and a player object, which in this case will be instantiated using the player constructor. We will also store a reference to a game object in the game attribute. To store the reference, we will have to instantiate the game class. Now, since game class is a singleton, there will be only one instance and we will get a reference to that instance. But we still need to pass in the path to the words.txt file so that it is initialized with the correct words. So we do os.path.join, os.path.dir_name underscore file. This gets the directory name of the current file, and to that directory we will join the words.txt file name so that we can access the words.txt file within this class. We will also set an active attribute to be 0. This attribute will store the number of players still playing the current round. At the beginning, since there is no active round, it will be set to 0. Let us also resolve these import errors by importing the necessary libraries. We first import OS, then from source.game, we import game. From src.player, we import player. And that should fix these import issues. Now let's add a bunch of methods to handle player addition and removal from a room. We write the add player method to add a player to the current room. So self.players, player name is equal to player. We're creating a new player with the player name and the player ID. At the same time, we want a method to remove a player. We first check if they're currently playing a round, if the room is active. So that would be done as follows. This is just checking if the current player is done with the current round. If they are not done, then we also need to update the active attribute by subtracting 1, because that's one less player that's actively playing the current round. After that, we need to delete the player from the dictionary. And a final thing to do is to check if the player is the host of the current room. And if they are, we need to update the host to be someone else in the current room. However, we can only update the host if there are other players in the current room. So we'll have that check in here as well. Num players in room. We'll call this method to count the number of players in the current room. And if it's not equal to 0, that is, if the room is not empty, then the host will just be randomly selected. We will convert every player in the current room, every player name, into a list, and we'll get the first person in the list to be the next host. Let's also define this numplayers in room method now. This is simply going to return the length of self.players dictionary. That is all to do with the room handling. Now let's implement methods to start and maintain a round within a room. We'll need a setup method to set up the current room for the next round. We'll do this by first generating the word for the current round by calling the generate game word method that we wrote in the game class. Then for each player in the dictionary self.players, we will call their reset method. And finally, we will set the number of active players, that is the number of players who are still playing the current round, to be the number of players in the current room. Once the game has begun, we need to provide methods that will allow us to play out a player's guess. We'll do that with the following method, def player guess. We pass in the player name, their guess, and the time at which they made the guess. First, we want to check if there is a word in the current round. That is, we want to make sure that the player is not hacking and getting to the game page incorrectly, and they have gotten here after the round has started. So if there is a word for the current round, we will get the result of running the guess through the game.run guess method. This will check the guess against the original word, and it will return us a status as to whether it's in the dictionary, it's the correct word, or the status of each character. We then pass that result list into self.players, player name, dot update after guess method to update the player's internal attributes after their guess. And we get a ret value returned from the method. This value indicates whether the player has completed the current round or not. If they have completed the round, then we can decrement the number of active players by 1, and we just return the completion status to the calling function. However, if the player has gotten to the current page incorrectly, then we will simply raise an exception that will be handled by the calling function. The calling function may also want to know the leaderboard of the current room, so we'll write a leaderboard function that will return the leaderboard. The leaderboard will contain the statistics of each player and will rank them based on their performance. The ranking we will use is as follows. We're going to sort the players based on whether they've solved the puzzle or not, and that will be given a higher priority to the number of guesses taken, which will have a higher priority than the time taken. So if you solve the puzzle, you'll be higher up in the leaderboard, and if you have multiple people who have solved the puzzle, the tie will be broken based on the number of guesses, so the fewer guesses, the better. And if the number of guesses are the same, then the final tie will be broken by the time taken to solve the puzzle. Inside this function, we will create two lists, a ret leaderboard and a ret IDs. The ret IDs list will contain the IDs of the players that have completed the current round. That is because we want to display the leaderboard only to the players that have completed the round and not the ones who are still playing. Next, we will iterate through each player in the players dictionary. Values, and then each player, if they are done, if the player is done, then we will add them to the leaderboard. We will add their name, their completion status, the number of guesses, and the time they took. We will also add their session ID to the return IDs list. We will sort the leaderboard based on the criteria that we identified previously. We will pass in a lambda function, which will take each item in the leaderboard list and sort it in this order: not item 1, item 2, and item 3. The reason I am using not here is because the sort function by default sorts from smallest to largest, and the completion status has a larger value than the incomplete status. So to ensure that the completed players are ranked higher, we need to negate their completion status so that they are sorted at the top of the list. The other two values, the number of guesses and the time taken, are sorted from smallest to largest because we want those values to be as small as possible for players at the top of the leaderboard. After sorting, we will return the IDs of the completed players and the leaderboard. We will also add a couple of helpful functions here. Get player guesses, and get player keyboard. These functions will allow us to return the guesses and the keyboard of any player specified so that they can be displayed on the front end. It will simply be a return self.players player name dot guesses, and similarly dot keyboard. That is everything that the room class needs to do. We will create rooms and control the rooms from the web server class, which we will write next. The web server file contains a server class which will handle all of the server logic on the back end. Let's implement that class now. We'll make the web server class be a singleton again because we want to have only a single website instance running at any point in time. First, let's import a couple of things that we'll need. First, we'll get the randint function imported again, and then from source.room, we'll import the room class. Let's now define the server class. Since we want it to be a singleton class, we'll use a similar strategy to before. We'll override the new method if the instance is equal to none. We'll create a new instance. And we will return the instance to the caller. We'll also write the init method. We want the server class to store three main mappings. First is a mapping of active rooms. This will be a dictionary. Let's also import those typing hints. This way we can improve the autocomplete. So from the typing library, let's import list and dict. That should be enough. So active rooms will be a dictionary mapping strings to room objects. Then SID username here will be a dictionary mapping strings to strings. And we want to have a dictionary named active players mapping strings to strings again. Active rooms dictionary will be used to map a room code to a room object. The active players will be used to map the player name to the room they're part of, so their room code. And SID username will map the player's session ID to their name. Now let's write a couple of helpful methods to use the server object. First is contains user. This method will check if the username is in the current website or not. This will return if there is a user on the website with the current username. So that's just a quick check if username is in self.activePlayers. Then we also want to check if a user is online. So this would check if their user ID is in the SID username. That will be done in the following method, contains user ID. We also will have a option to add a user to the website. We'll use the user's username and their user ID. We will say that the user is active and we'll assign them to a default room of -1. That is, they're not part of any room yet. And we'll create a mapping from their user ID to their username. Similarly, we need a method to remove the user from the website, which would happen when they log out or leave. To do this, we will accept only their user ID. We'll get their username from the mapping that we've created in SID username. And then we'll get the room code from the active players mapping using their username. If the room code is not -1, that is, they were part of a room, then we want to remove them from the room. This will be a method we will write next, the remove player from room, which will take in a room code and a username and remove the username from the room. Then we want to delete the mapping between the username and the room code in self.activePlayers. We also want to delete their mapping in the SID username dictionary. And we want to return the room code. This is to delete the room if there's no one left in the room. As mentioned, let's implement the remove player from room method now, which will accept the room code and the username. And along with this, let us also implement an add player to room method to add a new player to a room. In the add player method, instead of taking the username, we will take the user ID. We'll get their name using the SID mapping again. And then we will add them to the active rooms as follows. Oh, this should be active rooms. Add player. We'll pass in the player name and the player ID. Oh, it should be username and user ID. We'll also map the player name to be to the room code that we just added them to. That is how we would add a player to a room. Then to remove them, we need to reverse these steps. So we go to the active rooms, to the room code that's been provided, and remove the player. And then in active players, we set the player name to be -1. This should be username. And finally, we will make a call to remove the room and pass in the room code. This is another method that needs to be implemented, and we'll get to that right now. And just as before, we need a method to create a room as well. Except to the create room, we'll pass in the host ID rather than a player name. Another quick change I want to make, I'm just going to rename this method to be remove user ID because we're removing the user based on their user ID. Let's now complete the create room function. We'll generate a random room code in the range of 100,000 to 999,999. And if the randomly generated room code is already in an active room, then we just try again. Once we have a new, unique, and valid room code, we will create the room. In order to create the room, we'll need the host, which will be the username of this host ID, which we get from the SID username mapping. And using this, we can create a room. So in the active rooms mapping, we create a room object for the current room code using the room constructor. And we map the current host to the room code. And we return the room code. To remove a room, we take in the room code and we try to remove it. We'll create an assertion where we check the number of players in the room. We get the number of players in the current room and check if it's equal to 0. And we have an assertion to do that. If the assertion raises an error, then we catch it in this except block and we move on. Otherwise, if the exception is not triggered, then we can delete the room because there is no player currently in the room. We'll now need a method to get the number of players in the current room. Here too, we'll use the try except block, and we'll try to return the number of players in the current room. which we can get by calling the numplayersinRoom function for a room, which we defined in the room class. However, if the room does not exist in the dictionary, then that will throw an error, a key error, which we will catch in the exception and return 0, because a non-existent room has no players. Let's continue adding a few more helpful methods to the class. We'll add this called isValidRoom. That will check if the room code is a valid room or not. Using this, we can also edit the numplayersinRoom method to check if the room code that's been passed in is valid, and if it is, to remove it, and if it's not, to return 0. But we could have exceptions arising from other sources, which we want to catch in here and not crash the website, so I'm still going to use the try except block. A couple more helpful methods that we can add here are to check if the host passed in is the host of the current room, which we can do as follows. Once again, we will use the try except block, where we'll get the host of the room code and check if the host is the same as the host that's been passed into the function. And if it is not, then return false if there's any error. We'll do a similar thing to check if a room is active, that is, if there is a round that's currently running in the room, because we do not want players to join in the middle of a round. So we will write an isRoomActive method for that and check if the room code is active. If there's any error, we will assume that the room is active to avoid any possible bugs that could arise. Those are all the methods that we need for bookkeeping in the web server class. Let's next implement some methods to run the gameplay using the room, player, and game classes. The first of these will be to set up a room. Which will accept a room code. And it will try to set up the room in active rooms. However, if there are any exceptions that could arise, like the room not existing, we just want to pass on. Using a similar structure, we want to make a player's move if they're in an active room. This would require a few more arguments. We need the room code, the player name, their guess, and the time. So we will call the player guess method in the room class, and we'll pass in the player name, the guess, and the time. And this will return whether they've completed the game or not, whether the player has finished the current round. If there is an exception, we want to return false, so the player has not completed the game. We also need a couple of getter methods. So for a room, we might want to display the leaderboard to all the players that have completed the round in the room. For that, we need a def get room leaderboard method. That will take the room code and it will return the leaderboard of that room. by calling the leaderboard method to the calling function. Similarly, we might want to get the current word for a room, and that will be done in a method called getRoomWord. We will once again accept the room code, and we just return the word here in the room. And finally, we might want to get the player's guesses and the player's keyboard to display in the front end. To do that, we'll write two methods, def get player guesses, for which we need the room code and the player name. And before I forget, the self as well. Oops, incorrect. And get player keyboard. Here we will try to return the guesses of the player in the room code with player name. And if there are exceptions, we want to return a string or a list error indicating an error, the calling function. Similarly, we want to do the same thing when we're trying to get their keyboard. And with that, we have written all the methods that will be useful in the server class. Now all that is left is to put together all the classes that we've written in the app.py file to coordinate between the backend and the frontend code. App.py will use Flask and Flask.SocketIO to establish WebSocket connections between the frontend and the backend. And this way we can maintain real-time communication between the frontend and the backend, allowing for a smooth gaming experience. Let us start implementing app.py by importing the necessary modules. So we will need the import socket. Then from Flask, we will need to import, there should be lowercase f, Flask with a capital F. I can type render template and request. Then from Flask, socketIO. We want to import socketIO, join room and leave room. And then from source.webserver, we want to import server. Now let's create our Flask application as follows. And we will enable WebSocket communication for this app by passing the app into the socketIO constructor. And we will also initialize our backend web server here. Now we can get to defining functions and decorating them with Flask decorators to connect the backend to the front end. We'll first write a function to load a web page. This function will simply render the template HTML page at index.html. And this function will be called whenever a get method or a get request is made to the root URL, which we will define later. In fact, let's do it right now. To run the web server, we will simply create this if name equal to main check, and within here we will print that we're starting the server, we will print the URL to play on. Now this URL would work only within your local network, so keep that in mind. The local network would be your computer's IP address, which we can get using the socket functions. So get host by name, socket.get host name. This will get the host name and then pass it to get host by name, and that will return to you the IP address. And in that IP address, we want to go to port 5000. And finally, we can run the application using socketio.run, which will in turn make a call to app.run, which you would be familiar with if you used only Flask before. We would need an app.run method to run the application, but we're calling socketio.run in order to start up the WebSockets communications, and that method will in turn call app.run. So we want to run this app. The host will be 0.0.0.0. This IP address is to ensure that any requests made to your machine's IP address get routed to you, and the port we're exposing will be 5000. Now, if we ran this file, we would end up running the application, but we would not have any support to navigate between the web pages. We would only render the index.html page. So let's add the website functionality then. As a quick refresher, there are 5 pages in our website. We have the login page, which then goes to the lobby, which would then take you to a room. From the room, you would start a game. And at the end of the game, you would be on the end page until another game is started, in which case you would go back to the game page. We will implement functions to encapsulate these transitions and return error messages, if there are any, to the front end to display. We'll start off by writing the login user function to log a user in to the website. This function will accept a parameter called data.json, which will be a JSON object sent by the front end. In order to receive it from the front end, we will use the socketio.on decorator, and this will be triggered on the login user message. If you recollect from the front end video, when we want to log the user in, we emit a message on the WebSockets connection with the header login user and the data encapsulated in this JSON object. That message will be received here in the login user function because we're wrapping it up in this decorator, which looks for a message with the header login user. Now, we want to log a user in if they're not already logged into the website, and if their username is not already taken on the website. So we need a couple of checks for this. First, to see if the user has already logged into the website, we will use the server.contains_user_id method and pass in the session ID in the request. This will let us know if the user is already logged in, and if they are, we do not want to log them in again. So we will emit our own error message to the invalid endpoint and pass the following error message in a JSON object. You are logged in. And return. If they're not already logged in, we will get their username from the JSON object in the username field. And we check if the server contains this username. If it does, we once again return an invalid message, this time saying that the username is taken, but if it's not taken, then we can add them to the server using the add user method and pass in their username and their user ID and emit a message that they have logged in successfully. This message has the header log invalid username because we now want to call this function on the front end where we turn off the login page and turn on the lobby page. To that function, we want to pass the following information in a JSON object. We want to send their username again. And we want to send it only to the user that just tried to log in. Now, this is another thing that we need to add to the other request messages. We need to specify to which users we want to send the message, because if we do not do this, then by default, the message will be sent to all users, and that is not what we want in this situation. Similarly, we will write other functions to handle user behavior in the 5 pages and the transitions between them. The next function would be when the user wants to create a new room. That time we expect a message with the header new room, and we will write a new room function here. We don't expect any JSON from the front end for this. In this new room function, we will create a new room using the create room method that we previously wrote and pass in the user ID. The method will return to us the room code, which we will store here. Then we will join the room with room code. So this is to create a new room and join it and have this information stored in the WebSockets connection. So the WebSockets has an option to send messages to every player in a room, and we're leveraging this here by joining a room. And then we will return a message to the front end that the room has been joined successfully and that the player can now wait in the room. So another socketio.emit message, and we go to room valid endpoint, and we pass in the room code, the room players, which is the number of players in the room. This should be a colon here, which is server.num players in room code, and we want to send this to the room code. The reason I'm not using a session ID here is because I want to send this information to everybody in the room. So by using room code, I am telling the WebSockets connection to send it to every player in the current room. And the way it knows every player in the current room is because we joined the room using the join room function here. In the code on the GitHub, you would see all of this wrapped up with some additional error handling to account for errors that may arise. But for the purposes of the demo here, I'm not going into that. Similarly, we also want to give the players the option to join a room and not create their own room. So we need to handle that endpoint as well. So if the endpoint is join room, we will have a join room function. This function will also get a JSON object from the front end. From the JSON object, we will extract the room code that the player wants to join. We will have to first verify that this is a valid room, because the player could enter any room code. So we call the isValidRoom method that we previously wrote, pass in the room code, and if the room is valid, then we will add them to the room, and if it is not, then we will emit an error message that the room is not valid. Invalid error, not a valid room. Within this if statement, we also want to check if the room is active. That is, if there's already a room running, then we do not want any player to join the room yet. So we'll call the isRoomActive method that we wrote. If it is not active, then we can add the player to the room using the addPlayerToRoom method, pass in the room code and the user session ID, and join the room for the WebSockets connection. And once again, emit this message that they've joined a valid room in here as well. However, if the room was active, then we will once again emit an error message that they cannot join a room that is active. The next endpoint that we need to cover is the start game endpoint, which is when the host of the room tries to start a game in the room page. So that would be the following endpoint, socketio.on start game. We will define a start game function, which once again takes in a data JSON object, and it will extract the username. And the room code. And then it will check if the username is the host of the current room, because we want to make it so that only the host can start a game. So we add that check-in. If they are the room host, then we also want to check if this server is active. If it is not active, then we can set up the game by calling the setup room method and passing in the room code, and then sending a message to the front end using socketio.emit again to the endpoint game load. And we'll pass in the keyboard wrapped in a JSON object. Since the starting keyboard is the same for everybody, we can just get the keyboard of the host. And we can pass it to the room code. So everybody in the room can start playing the game. If the room is not active, then we once again have some error handling. and we will say that the room is active. And if they're not the hosts of the room, then once again, we'll have some error handling to indicate that only the host can start a round. The final endpoint which we need to cover is the game guess endpoint. This is when a player makes a guess. We will need to update their player object attributes on the backend and return information about their guess and move on to the end page if they have solved the puzzle. So we have a game guess function which takes in a JSON object as well. And in here, we have to do the following. We have to process the player's guess. And there are a few options here. It's either not a valid word. Alternatively, it is a correct guess. Another option is that they have made an incorrect guess, but they still have guesses left. And the fourth option is that they have no guesses left. So if it's an invalid word, we ask them to try again. If it is a correct guess, we go to the end page and display the leaderboard. If it's an incorrect guess and they have guesses left, we update their keyboard and display their guesses. If they have no guesses left, they go to end page and view the leaderboard. So to implement this, we'll need to get the following data from the data.json object that we received. First is the username. Just copy it from here. We'll also get the guess that was made. And the time. Now with all of this information, we can use the make player move method in the server and execute the player's current move. And we'll get a Boolean value as to whether they have completed the round or not. If they are done, then we get the return IDs and the leaderboard by calling the getRoomLeaderboard method that we wrote for the server. And then for each ID in the return IDs, we will send the leaderboard to. This way, all completed players can view an updated leaderboard. And the JSON object will contain the data. So we get the room word. And the leaderboard that we just got. And the 2 is to the ID. However, if they're not done, then we want to get their guesses and we want to view their latest guess. The first one is to check if it's an error. Now, this was just some error handling that we added in webserver.py. If getPlayerGuesses encounters any exceptions, it will return a guesses list, which will just contain error. And if there is an error, we will just mention that there is an unknown error to the front end. Let me just pull this from here, an invalid message. Could have probably made that a lambda or a function so that I didn't have to keep pasting it everywhere, but it is what it is. The error is unknown error. Otherwise, if the latest guess was a word not in dictionary, then we just want to remove this from the guesses list because we don't want that to count as a guess, and we want to return to the front end that the guess was invalid. In fact, I'm probably going to use an F string here and put the guess made and say that it's not in the dictionary. And the only other option is that the guess made was valid, but the game wasn't completed. In which case, we will emit a message to game valid guess endpoint and pass to it the guesses made so far by the player and their keyboard, highlighting all the keys they've used and the status of the characters. And we want to send this to the request.sid because this is the information for a single player about their guess. Those were all the methods necessary to establish a communication between the front end and the back end. We still have one final function that we need to implement, and that is the disconnect function. This function will be called whenever the SocketIO connection detects a disconnection. That is either the player exiting the game or closing the app. When this happens, we want to make sure that we clean up the backend so that the data of past players do not remain on the server and then slow it down. To do this, we just check first if the user ID of the player that just disconnected is on the server. If it is, we get their room code by removing them from the server using the remove user ID method. And if the room code is not equal to -1, then we want to leave the room that we joined in the WebSockets connection by calling the leave room method. And that is it. That is the entire code necessary on the back end to integrate with the front end and run the web application. I hope you enjoyed this series and found some value out of it. Please do let me know if you would like to see any improvements in future series and if you have any ideas for projects that you want to see built. I'll see you all in the next one.